an era defined by a growing need for sustainable solutions, the field of architecture is undergoing a profound transformation. This transformation is not just about aesthetics or functionality, it's about creating buildings that are in harmony with the environment. As cities expand and populations soar, the demand for energy-efficient and environmentally friendly buildings has never been greater. The challenge is to meet this demand without compromising the health of our planet. Traditional architectural practices, often reliant on fossil fuels and resource-intensive materials, are being challenged by innovative approaches that prioritize sustainability and harmony with nature. These new methods are not only more eco-friendly, but also more cost-effective in the long run. Among these groundbreaking innovations, wind-integrated buildings stand out as a testament to human ingenuity and our capacity to harness the power of natural forces. These buildings are designed to capture and utilize wind energy, reducing reliance on non-renewable resources. These structures, seamlessly blending cutting-edge technology with elegant design, represent a paradigm shift in the way we conceive of and interact with our built environment. They are not just buildings, they are living, breathing entities that contribute to the ecosystem. By integrating wind turbines and other wind harnessing technologies directly into their design, wind-integrated buildings offer a compelling solution to the challenges of urban sustainability. They provide a way to generate clean energy right where it is needed most. The concept of wind-integrated buildings is not entirely new. Historical examples show that humans have long been fascinated by the potential of wind energy. For centuries, architects and builders have sought to harness the power of the wind for ventilation, cooling, and even power generation. These early innovations laid the groundwork for the sophisticated systems we see today. Traditional windmills, dotting the countryside for generations, serve as a testament to our long-standing fascination with this invisible force. They remind us that the quest for sustainable energy solutions is deeply rooted in our history. However, it is only in recent decades, with the advent of advanced materials, sophisticated engineering techniques, and a heightened awareness of climate change, that wind integration has emerged as a viable and increasingly popular option for urban architecture. This modern approach combines the wisdom of the past with the technology of the future. This essay will delve into the fascinating world of wind-integrated buildings, exploring their underlying principles, the myriad benefits they offer, and their transformative potential for the future of our cities. We will examine how these buildings can help mitigate climate change and promote sustainable urban living. From the elegant curves of skyscrapers adorned with vertical axis wind turbines to the sleek facades of residential buildings incorporating innovative wind-catching features, the possibilities for wind integration in architecture are as diverse as they are inspiring. Each design is a unique response to the specific environmental challenges of its location. As we stand on the cusp of a new era in sustainable design, wind-integrated buildings offer a beacon of hope, demonstrating that we can create a future where our cities not only coexist with nature, but thrive in harmony with it. This vision of the future is not just a dream. It is a tangible reality that we can achieve through innovation and commitment to sustainability. Wind, an inexhaustible and ubiquitous source of renewable energy, holds immense potential to revolutionize the way we power our cities. As we continue to seek sustainable solutions to our growing energy needs, wind energy stands out as a beacon of hope. Unlike fossil fuels, which release harmful pollutants into the atmosphere, wind energy is clean, green, and sustainable. It offers a way to generate electricity without contributing to climate change or depleting natural resources. By tapping into this abundant natural resource, wind-integrated buildings can significantly reduce their reliance on traditional energy sources, mitigating their environmental impact and contributing to a healthier planet. This integration not only supports energy efficiency, but also promotes a forward-thinking approach to urban development. The principle behind wind energy is deceptively simple. It harnesses the natural movement of air to generate power, a concept that has been understood for centuries, but is now being applied in innovative ways. As wind flows over a surface, it creates areas of high and low pressure. This pressure differential is the key to capturing wind energy efficiently. Wind turbines, strategically positioned to capture this pressure differential, are set in motion, converting the kinetic energy of the wind into mechanical energy. This process is both elegant and effective, showcasing the power of nature harnessed through human ingenuity. This mechanical energy is then used to drive a generator, which produces electricity. The seamless conversion from wind to electrical power is a testament to the efficiency of modern wind turbine technology. In the context of wind-integrated buildings, this electricity can be used to power the building itself, reducing its dependence on the grid. This not only lowers energy costs, but also enhances the building's sustainability profile. The integration of wind turbines into buildings can take on various forms, each with its own advantages and aesthetic considerations. From sleek modern designs to more traditional setups, the possibilities are vast. Vertical axis wind turbines, resembling giant egg beaters, are particularly well suited for urban environments due to their ability to generate electricity even in turbulent wind conditions and their relatively low noise levels. Their unique design allows them to capture wind from any direction, making them highly versatile. Horizontal axis wind turbines, the more familiar propeller-like design, are often integrated into the roofs or sides of buildings, harnessing prevailing winds to generate electricity. These turbines are known for their efficiency and are a common sight in many wind energy projects. Beyond wind turbines, architects and engineers are constantly exploring innovative ways to harness the power of the wind in their designs. This includes integrating wind energy solutions into the very fabric of buildings, creating structures that are both functional and environmentally friendly. Some buildings feature wind scoops, strategically placed openings that funnel wind through the building, providing natural ventilation and reducing the need for energy-intensive air conditioning. This passive cooling method is both effective and sustainable. Others incorporate wind baffles, vertical elements that redirect wind flow to create areas of high and low pressure, enhancing natural ventilation and reducing wind loads on the building. These innovative designs demonstrate the potential of wind energy to transform our built environment. The successful integration of wind power into a building's design requires a holistic approach that considers the building's location, orientation, shape, and intended use. Architects and engineers work in tandem, employing sophisticated computer modeling and wind tunnel testing to optimize the building's design for maximum wind energy generation and minimal environmental impact. The first step in designing a wind-integrated building is to conduct a thorough analysis of the site's wind resources. This involves collecting data on wind speed, direction, and frequency throughout the year. This information helps determine the optimal placement and type of wind turbines or other wind harnessing technologies to be incorporated into the building's design. Once the wind resource assessment is complete, the next step is to design the building itself in a way that maximizes its wind energy potential. This may involve orienting the building to face prevailing winds, incorporating wind scoops or baffles into the facade, or shaping the building to create areas of high and low pressure that enhance wind flow. The integration of wind turbines into a building structure must be carefully considered to ensure both optimal energy generation and structural integrity. Vertical axis wind turbines, with their lower center of gravity, are often integrated into the building's facade or roof, while horizontal axis wind turbines may be mounted on towers or masts, separate from the main structure. The electricity generated by the building's wind turbines is typically fed into the building's electrical grid, offsetting its reliance on traditional energy sources. In some cases, excess electricity can be stored in batteries or sold back to the grid, further enhancing the building's sustainability and economic viability. Wind-integrated buildings offer a compelling solution to the environmental challenges facing our cities. These innovative structures are designed to harness the natural power of the wind, transforming it into a reliable source of clean energy. As urban populations continue to grow, so too does the demand for energy, resources, and infrastructure. This increasing demand puts a strain on our planet's finite resources and exacerbates environmental issues. Traditional building practices, often reliant on fossil fuels and resource-intensive materials, contribute significantly to air pollution, greenhouse gas emissions, and other environmental problems. These practices are not sustainable in the long run and pose a threat to our planet's health. Wind-integrated buildings, by contrast, offer a more sustainable and environmentally friendly approach to urban development. They represent a shift towards greener, more responsible construction practices. By harnessing the power of the wind, these buildings can significantly reduce their reliance on traditional energy sources, mitigating their carbon footprint and contributing to a healthier planet. This shift not only benefits the environment but also promotes energy independence. The environmental benefits of wind-integrated buildings are numerous and far-reaching. They extend beyond just energy savings to include broader ecological impacts. Firstly, wind energy is a clean and renewable source of energy that produces no harmful pollutants or greenhouse gases. This makes it an ideal solution for reducing the environmental impact of urban areas. Unlike fossil fuels, which release carbon dioxide and other pollutants into the atmosphere, wind energy harnesses a natural and inexhaustible resource, making it a key component of a sustainable energy future. This transition is crucial for combating climate change. By reducing our dependence on fossil fuels, wind-integrated buildings can help mitigate the effects of climate change and improve air quality in our cities. Cleaner air leads to healthier communities and a better quality of life. Secondly, wind-integrated buildings often incorporate other sustainable design features, such as green roofs, rainwater harvesting systems, and energy-efficient materials. These features work together to create a holistic approach to sustainability. These features further reduce the building's environmental impact and contribute to a more sustainable urban environment. They also enhance the aesthetic appeal and functionality of urban spaces. Green roofs, for example, provide insulation, reduce stormwater runoff, and create habitats for urban wildlife. They transform otherwise unused spaces into vibrant green areas. Thirdly, wind-integrated buildings can help reduce the urban heat island effect, a phenomenon in which cities experience higher temperatures than surrounding rural areas due to the absorption of heat by dark surfaces such as roads and buildings. This effect can exacerbate energy consumption and discomfort. By incorporating green spaces and using lighter-colored materials, wind-integrated buildings can help reflect sunlight and reduce the urban heat island effect, creating a more comfortable and livable urban environment. This not only benefits residents but also contributes to the overall resilience of cities.